Welcome everybody to the Conservation Impact Evaluation and Implementation Science Seminar Series. My name is Alan Blackman. I work at the Inter-American Development Bank, and along with Julia Jones at Bangor University, hosting the seminar series this year. But all of the real work for the series is done by three of our volunteer board members, Elias Cincineros at UT Dallas, Renzo Guiducci at the University of Bonn, and Alex Caruana at Oxford University. The goal of the seminar series is to advance evidence-based biodiversity conservation efforts around the globe by supporting the adoption of counterfactual approaches to impact evaluation. You can find out more about the working group and the seminar series on our website, which I'll tell you about in a minute. You can also engage with us on social media. And on the website, you can sign up to be on our email list. So if you are not familiar with the website, I strongly encourage you.
I don't know if you know, but your slides are not in presenter mode if you wanted them to be. I don't know if you did.
Oh, yeah, they are, and when I'm looking at them. So
am I the only person seeing the slide deck? Or
let me try it again.
I can try stop sharing. Would that work?
There we go. Yep, that works.
Awesome. Okay. So if you're not familiar with the website, I strongly encourage you to check it out. Among other things, it's got a repository of all of the seminars, recordings of all of the seminars for the past several years, which is an amazing resource. If you'd like to get involved in our working group, please do that. We're looking for two specific types of volunteers now. One is a resource library volunteer to help compile the literature, the evidence on counterfactual impact evaluations. And we're also looking for an editorial assistant to help with our blogs. If you have other ideas for work to do with us, please reach out to us through our website. So last week, we had Jan Borner, who was talking to us about impact evaluations across borders and other spatial discontinuities. Today, we're very happy to have with us Santiago Saavedra, who's an associate professor in the economics department at Rosario University in Bogota. He's going to be talking to us about evaluating the private provision of conservation in the case of African parks. So before taking his job at University of Rosario, Santiago has also worked as a visiting professor at Stanford University and at the University of Colorado at Denver. His research focuses on development and environmental economics, and in particular, how economic development and governance affect natural resources. He's published in top journals, including the Journal of Public Economics, JIBO, the Journal of Economic Behavior and Organization, and the European Economic Review. He has a BA in economics and a BS in math from Los Andes University in Bogota, and a PhD in economics from Stanford. Before we start, just a little bit of housekeeping. So Santiago is going to talk for about 30 minutes, and then we should have 20 or 30 minutes at the end for Q&A. If you have a question, please feel free to type it into the chat, and Elias, who is going to be moderating the Q&A, will curate it and read it out to Santiago. The seminar is going to be recorded, and it'll be available along with all the other seminars on the website. And that's it. Santiago, thanks so much for joining us, and please take it away.
Well, thank you very much for the invitation and the introduction. It's the first time we are presenting this paper broadly. But it was great you invited us because it kind of put a commitment device so that we finished the slides and had like a clear picture to present. So as Alan told you, this paper is about the private provision of conservation using the African Parks NGO management of parks in Africa. And it's co-authored with Prakash Mishra from Dartmouth, who should be in the audience. So the motivation, I guess all in this group knows that land protection is a cornerstone of environmental policy, and in particular that deforestation contributes to 12% of annual CO2 emissions. That's basically the size of the European Union emissions, so it's a really important sector to study. And many countries in the world, almost all of them, use protection of land as a conservation tool. But as economists, we know there is a trade-off between possibly the environmental benefit and the economic development of the communities. So in this paper, we want to ask whether private management of parks improve environmental outcomes. We already know, like in general, when there are protected areas, there is an improvement in environmental outcomes, but we want to understand whether when the parks are allocated their management to a private entity, it will improve environmental outcomes. And also, whether this additional investment that the private entity might bring to improve environmental outcomes will bring economical benefits to the local communities. So we want to study the both sides of the trade-off. To do that, we are going to study the African Parks NGO, who has acquired 18 national parks in Africa for the years 2021 to 2023. So the number right now is a little higher and keeps growing, but for our study period, which is 2001 to 2023, we are going to have 18 national parks throughout Africa. And when they are acquired the management of the park, they start doing more enforcement of anti-poaching and anti-logging laws. So better enforcement on a state with limited capacity. They make investments in airstrips and vehicles that hopefully will bring economic opportunities via tourism. So increase tourism to these parks. And as I mentioned to you, it's an alternative to state capacity that in many developing countries, they don't have the time or the resources to invest in natural resources. So we expect that by combining 1 and 3, private management should improve environmental outcomes compared, and this is important in this impact evaluation group, the counterfactual is a national park managed by the government. So it's not a study of protection versus no protection, it's when there is private management compared to when the park continues its traditional government management. So we expect an improvement in environmental outcomes, while when you combine 1 and 2, the ex-ante expectation is uncertain. We don't know whether this investment will bring additional revenue to the local economy. That's the expectation with this number 2 like investment, but also number 1 might be affecting the community. If they relied on selling the horns or the animals itself or the wood from the forest, there might be a reduction in economic opportunities. So we might be looking at an uncertain economic effect. So a preview of results, in case you cannot stay for the full half hour, is that we have that AP managed parks show statistically significant reductions in deforestation. So good environmental outcomes. And also when we measure the outcome through carbon storage, because we will show you later that not all of the parks are forest. Many of them are savannas and other vegetation types. So that's why it's important to measure the carbon accounting in addition to only forest measurement. So in general, improvement on environmental outcomes, while we don't see a significant effect on economic activity. So economic activity is going to be measured with nighttime lights or road development. So we don't detect effects on the variables we use. And there will be some caveats at the end that maybe they are investing in education in the local communities, and we are not able to detect other variables that maybe in the future we will have the data, or in the future the improvements in education will translate on nightlight improvements. But for the variables we're using, so far we don't detect effects on economic activity. The literature is pretty large, and probably we're not making justice to many of the authors here, but in the interest of time, we decided to have like a short literature slide, which is basically saying, look, we know there is an effect of protected areas. They are effective conservation tool. Where we think our contribution lies is in this transition to private management of existing national parks. So we know that national parks work as a conservation tool. We want to understand whether the transition to private management helps even more. And then the economic effects of the protected areas, we know that in general, they can help the local economy by creating tourism. But so far, we don't have detectable effects in the case of this private management. So it might be because there are no additional economic effects. That might be an explanation. There was already some tourism and there is no additional tourism by the private management, or that they're investing in different variables. So that's kind of the preview of the talk. And now let's start digging deeper. This is basically what you get if you enter the website of Africa Parks. Basically, they work on biodiversity conservation. That is a variable that we are not capturing, but we're happy if any of you knows about like a good biodiversity panel, because we'll need variation in time of the biodiversity outcomes. So that's, like the first picture is the animals, and you will see it's one of their criteria. They also mention community development. That, as I discussed before, if they're investing in education, we cannot capture that with the satellite, but that's a possibility. And they also have pretty clearly the tourism part, of course, making emphasis on that is sustainable tourism in what they're investing. So this is their website. So to summarize, how do they select a park? They focus on large parks, like more than 500 square kilometers, because there is a fixed cost of the investment. So they don't want to take small areas. So they focus on large parks. They want to have a strong legal status of protection, that they don't have that much agriculture inside the park. This will be like a lot of conflict with the communities. And notice that they focus on large mammal populations. So that's one of their focus for selecting their anchor areas. So in general, they tend to select areas under relative lower observable pressure. So that's going to be important for our identification strategy. We need to select similar parks that could have been protected by African parks to estimate the effect. They have a comparative advantage on megafauna and tourism monetization. And they are focusing on low agricultural presence, but they still have other threats like poaching or illegal logging. So they still have to do a lot of work on enforcement. And in general, they want to scale the model and target by 2030, 15 additional sites. And they do this expansion to public-private partnerships. So they are management, a public national park, they are private management the park. Here is a map of Africa, and you have what we have in our data set. So you have some countries in gray where there are no parks in their study, some countries in blue where we have parks that help us in the identification strategy with the before after, if we don't focus on within country estimates. So the problem of focusing on only within countries that we reduce the sample, but we'll show you different estimations with or without the parks in blue, which are basically other countries, and where you should focus is the countries in red, which are countries where there is at least one treatment park. That is one park acquired by African parks. And I guess you have like the largest country, which is the DRC Congo, and other regions, mostly on sub-Saharan Africa. Another important thing to understand is the timeline. When are the parks acquired by African parks? That is going to be helping us with the identification of the difference in difference strategy before and after the acquisition. So you have here the flow starting 2003 with 3 parks acquired by African parks. And then slowly you can see like basically every year 2 or 3 parks with like a dry period from 2011 to 2014. But in general, this is the variation we're going to be relying before and after the acquisition. And you will see later that because the year that each park is acquired is different, then we're going to be using the Callaway-Santana estimator. Because the traditional diff and diff will present a problem given that there is variation on treatment timing. We use a lot of data, most of it remotely sensed, so deforestation from Hansen, the shapefile of national parks, that's basically how we draw the boundaries to measure deforestation. We have the harmonized global nighttime lights, because there was a change in the satellite in 2014. We use fires data. We have pending, and there is another opportunity, we use this presentation. We have been trying to get some data of African parks on the management, like the expenditures per park, the tourists per park. We have requested, but if somebody or is working at African parks or know anybody, we are happy to like get information from them and improve our paper. We use land cover data from the European Space Agency. So there's classification where it's forest, savanna, and we use the global administrative areas from GADM, which is basically the boundaries of the countries. So that's all the data we use for the paper. And we prefer to illustrate you that visually, right? So we have here in the center a national park. That's the boundary we got from the shapefile. And we can simply do a buffer around the park. That could be one region of analysis. Use the whole buffer of the park. You can see it includes the ocean in some cases. And when we want to study economic effects, you might say, well, you should not measure economic outcomes in the ocean. You will never see, I guess, economic activity there. There might be like an oil platform, but so what we can do is focus on the population buffer. So it's basically don't look at economic activity everywhere in the buffer, but focus only on economic activity where there is population living. And that's the white areas. So you can see that the whole buffer is reduced to a certain areas where there is population living. So let's focus the economic outcomes on where the population is living. That's one alternative. That you see here with the nightlights. So you can see nightlights in the full buffer. And if we do that, you can see that we have a lot of areas in black, which are basically zero lights, right? So if you focus on before and after the park, you will have a bunch of zeros, and it might not be fair. So we can just focus on nightlights where the population is living, right? So it's kind of like the entrance of the park or the community is living. So basically, we'll show you robustness using this population classification of the nightlights only on the areas where people are living. So the results are robust to that specification, but I think this is an example on the data we use. Some summary statistics. So basically, each row of the table is a different variable, and each column is a different sample. So in column 1, we have all the parks we have in the data. That will give us 2,745 parks. That's kind of the amount of parks we have in data. Column 2 is restricted to African parks. That's as I mentioned to you, it's only 18 parks. And you can immediately see, comparing columns 1 and 2, that African parks are larger, right? So if we include all the parks, we have tiny parks that are not a good comparison groups. So what we do in columns 4 and 5 is the match sample using the weights of the matching. So basically, column 4 is still the African parks, the same 18 parks, but because it's weighted, you can see a little change on the outcomes with the objective of matching column 5, or like column 4 and 5 matching each other, which is basically the non-AP parks, the control parks should be similar to the control parks. And that's the idea. We are only matching on environmental characteristics in 2001. Right, so like before the treatment, similar parks, and I guess that's another estimation. So we can do a different diff with all the parks or a different diff only with matched parks, and that's going to be what I'm going to show you in the regression table. So when you match, yes, control and treatment parks have on average 5,000 square kilometers, so like 10 times what African parks set as the minimum. In general, they have 60% tree cover, but they also have this transitional vegetation. So like small trees and a little bit of grasslands, not much on cropland, but you can see that 8% of the land is classified. 3% of the land is bare, kind of a little bit of desert areas. Water bodies, like 3%. And the nightlights buffer, when you do the full buffer, is 0.08. So like not much economic activity, because of the zeros I mentioned to you. And once you focus on the population buffer, you can see like more lights in this case of the parks. So that's kind of a descriptive statistics of all the parks, as standard deviations in parentheses. Okay, so what is the identification strategy? We want to study national parks in Africa acquired by African parks. So we're going to leverage the staggered park rollout. So we are going to have variation in treatment timing. And the control groups will be the publicly owned national parks. So we're not comparing against areas without national parks protection. It's against other national parks, but without the private management. That's our counterfactual. And we can focus on do an estimation with matching. So I'll show you both versions with matching and without matching. We'll focus on deforestation, land use as environmental outcomes, and economic activity with nightlights and roads. If you want the estimating equation, so we'll have outcome Y in part P in year T, with the variables I mentioned to you measured remotely. And then we have our beta, which is the coefficient of interest, which is what happens with this outcome after the park is acquired by African parks. So the interaction. We have park fixed effects. So still, if you think that there is certain characteristic of the park that it has certain altitude or a certain distance from the sea, well, that's will be absorbed by the park fixed effects. And we also have year fixed effects in case there was like a drought or a war, like anything that like affected all the parks simultaneously. We have lifetime fixed effects. So it's variation in before and after acquired parks that are not acquired. And again, as I mentioned to you, we don't use the traditional two-way fixed effect estimator because it will have problems, but Callaway-Santana estimator will deal with this variation in treatment time. And I guess here is the first slide of results. I show it to you in event study form. And in the next slide, I show you in table form. So what we have before acquisition is parallel trends. In general, there is no differential outcomes before the treatment. And what you can see with recover after the treatment is not immediate, which makes sense. It takes time to start managing the park, enforcing, hiring people, and doing anti-poaching efforts. So you can see that in the first years, there are no environmental effects, but after a while, you see positive environmental effects. In this case, tree cover on the left, and the story with CO2 is similar, like no effects before the treatment, so support for the parallel trends assumption. After treatment, immediately, there are no effects. It makes sense. It takes time for vegetation to regrow, but after around 5 years, you start seeing positive environmental outcomes. In this case, increased CO2 storage. So that's kind of a visual summary. So now let's get to the table, which is what sometimes economists prefer, which is basically a column per variable. So now we focus not only on the two figures I show you, and in panels, or if you want it by rows, different samples for estimation. So in panel A, we have the full sample, all the parks we have. In panel B, we focus on the match sample. So those parks that are similar to the African parks. So it's like the columns 4 and 5 of the summary statistics table. We see positive effects on tree cover. That is not statistically significant because it's like a stock. But when you measure it with the forest loss, which is the flow variable, you see a reduction in forest loss. That's column 6. And in general, not many changes in the categories of grassland, cropland, and bare. If something, there might be a switching from transitional vegetation to tree cover. That the way of adding them up, right? Because each type of ecosystem has a different CO2 content. And that's what we do in column 8. At the end, what is the net effect of having less transitional vegetation and more tree cover? Well, it's an increase on CO2 storage in the treated African parks. So on average, they had 625 in CO2 and the increase is 13. So it's like a effect size, if you wanted, of 2% of the CO2 captured. So there is more CO2 being captured, and that's the average treatment effect. On fires, that was another alternative, given that not all the park is forest. An alternative of better management of savannas is to have less wildfire loss. and the effect is basically zero, like in magnitude and statistically significant. We don't find any effects on fires. So effects are mostly on deforestation. And now we switch from the environmental outcomes to the economic outcomes that we have. And again, I show you 2 event studies visually, and then we go to the table where you see like all the outcomes and sample variations. So for night lights, we don't have statistically significant effects. And after the treatment, there are no statistically significant effects. If something a little bit negative some years, but again, statistically, we cannot reject the effect is zero. And with roads, that might be like a future economic growth. There are more roads. So you have here different units on years because the shapefiles of roads are not available yearly. This is like the Michelin guide. So it takes, that's why you have more space and like more noise because of the spacing on the years we have. Again, so parallel trends not as clear in the other cases, and then after the treatment, either zero effect or if something like some effects on some road construction, maybe after 9 years and 2 years. But again, statistically, when we go to the table, we don't have in general conclusions that will support that the results are in one direction. So for night lights, columns 1 and 2, roads column 3 and 4. So panel A, the full sample, all the parks we have. Panel B, the matched sample of similar parks. And then the odd columns, the full buffer, everything that is around the park. And the even columns restricting only to where population was living. Right? So it's kind of the different ways of measuring the economic activity. When we use the full sample, we observe a reduction in economic activity measured by night lights in the full sample. But once we go to the matched sample, the coefficient is not statistically significant, and the magnitude is like a third or a fourth of the effect. So that's why we prefer to say we don't detect effects, because the result is not consistently robust in magnitude for night lights. For roads, again, there is a positive and statistically significant effect when we use the matched sample and all the buffer. But when we do robustness to the population buffer or the full sample, the results are not robust. So that's why if you kind of aggregate the things we tried, we say there is no statistically significant effects, but there are some cases and a specification with the statistically significant effects. Then the last empirical exercise we did is, okay, let's try to understand this question we had on whether there is a trade-off between the environmental variables and the economic outcomes. So if there was a trade-off, we would expect to see like a clear correlation that maybe in the parks where there are environmental improvements, you might see negative economic effects. That could have been like a clear case of a trade-off. So what we did, and again, we only have 18 parks, so this is kind of suggestive, is let's do an estimation of an individual park treatment effect. So what is the effect in each park on night lights and on CO2? So each dot here represents an individual park acquired by African parks. And what you see is what's the effect on night lights and what's the effect on CO2. But we don't see any clear correlation. Like the coefficient is pretty low, and in general, you can see that there is not the case that the parks with more CO2 improvements that would have been up here on the left are those with negative economic effects. We don't see any point, and maybe I can draw in this area that you would say, okay, is the parks with the positive environmental outcomes that have like low economic outcomes. No, in general, we have like, look, this park had a positive environmental effect, no economic effect. Some parks with positive economic effect, but so in general, we don't see a clear picture. Again, it's only 18 observations, that is suggestive, and this is what we have so far. So to conclude, the institutional design matters. The private conservation management is associated with meaningful environmental improvements. So that's part of the objective of having this private management. They're helping a state with low capacity in management the natural resources. But it's important to notice that we need to be patient. You cannot expect, and we don't see in the event studies, any immediate effects. It's a medium run effect. It's basically like 5 years after transition. So we need to, and that's what they do, have long-term contracts. So that every investment they do, you will see it in environmental outcomes. But again, in the economic outcomes, we don't observe statistically significant effects. Although, let's caveat again, we are using islets and roads. There might be effects in other outcomes that are targeting, maybe like health and education. So remember, we're not measuring them, or they might take longer time to materialize in islets. Maybe once you educate kids, it will take 10 or 15 years once you see them improving economic activity. So in general, private conservation is guaranteeing sustainable environmental benefits without detectable short-run economic displacement in observed indicators. Thank you very much for listening, and happy to receive any question, comment, any data we're missing, any paper we are skipping. Like, it's literally the first presentation, so we're happy to get any feedback you might have.
Okay. Yeah, sorry if you want to have a word, Alan.
No, I just wanted to thank Santiago and turn it over to you, Elias, for the Q&A.
All right, so you will benefit, I guess, from us giving you the full conversation that is going on the chat. Yes, so I think this is great, and you can read it up. I try to organize it a little bit. Yes, so the first thing, the main discussion, I think, is on the institutional setup of these African parks, right? And if you can give us a little bit more insight into that, is what is actually their incentive structure, right? And I think like they didn't really purchase parks, right? But they are like co-managing parks. And how does that works, right? How as they are NGOs or non-profit organizations, what is the benefit and the incentive structure of them actually engaging into tourist activities, right? And how that will turn out. What is the change, the institutional change that happens between just parks, national parks, and those managed, right? If you can give us a little bit of insight.
Yes, so let me, I guess I'll go back to that slide that will help. So this is basically what they do they enter in a conversation with the national government of the country. They need to have the strong legal status to get into this long-term agreement because they're gonna do long-term investments, like a nursery or like a hotel. So like they're gonna invest, they're thinking on the long term, and they hope to get two kind of benefits. The first one is like the benefit of the tourism that is bringing like cash to them and like will cover some of the expenses, but there is also like the environmental global benefit. You know, like some people are interested in protecting nature per se, like via donations or other foreign governments, you know, like through international aid. That's basically what they're doing. And so in general, they have this incentive for like protecting the planet without the economic conservation. Not all of it is tourism. Some of it might be just pure improvement. And again, they have more resources than the national government. So again, it's a low capacity setting. So sometimes they don't have staff to monitor the border of the parks or to do investments. They might need to do, I don't know, a school in the area. The government doesn't have the money, but the NGO might be able to raise the money from external funding to the country.
And I'll just add to this answer, the usual structure of these long-term agreements tends to be like a 20-year agreement between African parks and a target country's government. And the incentive structure does vary within the African Parks Organization. So there are some where it's mediated by an upfront payment that's agreed between the target country and African Parks. And then African Parks is expected to be self-sufficient and be able to fund year-over-year operations through either donors or tourism revenue. So this kind of, in theory, means that increasing tourism is incentive compatible for African parks, right? Because they are financing future operations based on that source of revenue. The kind of interesting thing that, we are still in early stages of exploring is that like these contracts that because they have these 20-year timelines, we're kind of just coming up on like the first round of renewals of some of these African park initial contracts from the early 2000s. And so we're for the first time seeing like to what extent the incentive structure has been binding, right? To what extent governments are willing to say recontract, renegotiate, re-enter into these agreements with African parks. We've seen like some mixed success. So there have been two cases to our knowledge where African Parks was not granted a repeat contract initially, but then upon renegotiation was granted contract. So they currently manage all the parks that they managed at the beginning of the 2000s, but that doesn't mean they were uniformly successful at hitting whatever the government internal target was for blanket, like non-renegotiation proof renewal of contracts. So it's something we're definitely exploring because of the limited sample size. We're broadly able to characterize a consistent form of contract, but it's really hard for us to get at like contract-specific heterogeneity across only 18 parks. So hopefully that gives you some of the broad strokes.
Okay, so then let me slowly transition from the institutional knowledge to then your selection of covariates on matching, for example, right? Where you chose obviously a set which are all defendable and discussable, right? But the one question was, did you also make like interviews with these government agencies, how they selected those parks that are in the end treated?
No, so as I mentioned to you, we haven't been able to speak directly with African parks. That's something we wanted. And I guess the other part of the question is speaking with governments. We currently don't have funding. So it has been like a remote work. You wanted like satellite data, but we are definitely convinced that the people will be enriched by that. So yeah, any future funding, we might like do a visit and do interviews in the other side, or maybe like find some funding to have a survey fear. And the problem is there is like basically 15 different countries, or so it will be like an expensive endeavor, but we will definitely love that.
So now like to some measurement and data, yes, maybe you can just clarify what a tree cover is for you. Is it a continuous variable? How is it actually constructed here?
Yeah, so we are following the definition of the two data sets we use. So one is Hansen, which is basically deforestation events, so like 5 meters height. They don't tell apart plantations from like natural forests. They just see like removal of tree cover. So it's, I guess, with the caveats of the data we use. But what we think is in some cases, like in Colombia with a lot of palm oil, or Indonesia, it is an issue. As far as we are know, like in Africa, and especially focusing inside the national parks, the plantations confusion shouldn't be an issue. But again, we're using Hansen. And I guess for the other is the land cover of the European Space Agency. So like similar caveats of what they have.
So yes, because it's an aggregate to the parks, right? Just to finalize the question, the answer, right? It's a continuous variable in the end, right? Yes. Then Paul also asked about the nightlight outcome, right? And I chip into this with my experience, right? That of course this is a very noisy measurement, right? And in a like year-to-year panel structure, it's very hard to actually identify changes from nightlight, right? So yeah, what do you think about this, right? So,
No, so that's definitely a limitation of nightlights. I guess in Africa especially, that if there is a bunch of zeros, it's hard to measure poverty. A lot of people are transitioning to daylight imagery, but the products of poverty measurements of satellite data, using satellite data, they don't have the panel structure, right? So they give us the cross section, but they don't give us like back in time the information. That would be the alternative. So yes, I guess I share the limitations, but I guess it's the best we have for now, to have like the panel structure.
Yes, so one good alternative that I found is like world settlement footprint evolution, which at some administrative scale tracks better, like GDP changes from year to year or something like that. You could try that out. I posted. The other questions here were so because one of the main goals of the African parks is to reduce poaching, right? So which you are not really tackling here, right? Is maybe there is some data, maybe you can find some data on this, maybe because you have the case that you're comparing within park variations, maybe there are some cases where you could actually count hunting, poaching activities within parks, right? Because you don't need this for outside of parks information, right? Maybe there's also one database that was mentioned on elephants or mic data, which you can look up, yes. But yeah, as this is the main goal, what you think is there to do?
Yeah, definitely we will explore. When we did our research, we didn't find it with the panel structure and with the parks we need. We need at least the African parks and other parks in the control group. And again, the before and after. So we didn't find a data source with this, like enough coverage. I show you with rows, we have the limitation, but as long as we have before, after, treated and not treated, so we'll definitely check the data source you share with us, and that's super helpful. Thank you.
So another question on heterogeneities, right? So maybe you can look into these dimensions where each park has a different set of threats that they encounter, right? For example, and that's also what I saw from the nightlight picture that you showed, right? Like maybe some parks are actually more threatened by the surrounding than others, right? Which kind of other threats to biodiversity do they see? Maybe there are differential effects here, to look at.
Yeah, no, I really like that idea, and we can definitely try. Although it's 18 parks, but at least we can try 9 parks with high population density nearby, or in each border. Because maybe this park in the picture is easy to control because basically you need to block kind of only the north border if you want it, while the rest, I guess, is not traded by sea as much. So yeah, we could figure out a way of high and low population density with the caveat of 9 parks in each class, but I like that idea.
Okay, so that comes to an empirical comment also, right? 18 parks, right? Maybe you can try the generalized difference in difference methods, right? As in the end, your variation just with 18 observations, right, is pretty low, yes, to pinpoint effects, yeah. But yeah. These are suggestions. And of course, another suggestion on the empirical side, yes, you're testing 8 outcomes. They are not fully independent of each other, right? Be aware of like multiple hypothesis testing comments, yes, that, for example, now also Porphyro raised. That they are not truly independent to regressions, right? Yeah, otherwise, I think this is, I hope, much of what I covered. Now there are some comments coming in on, stories of, human right violations and of within these parks. So you can should look that up. Let me just try to read out more. So it's a vivid discussion. Sorry. So I'm not. So So, any chance of identifying the mechanisms for the effect on tree cover losses? Might it have to do with enhanced regulatory effort or community monitoring or any combination? So, yeah.
That's I guess what we wanted to get from African Park, a little bit of detail, like instead of the treatment being African Park managed, if we know that in this park they, I don't know, hired a lot of community, but in this park they hired a lot of guards to protect the park. So again, we could do like, again, with 9 parks heterogeneity, high and low anti-poaching efforts versus high and low community involvement. We could try to tackle these questions that currently we cannot explore. But yeah, we definitely would love that. So again, any data on that front will help us.
Okay. So I think it's one of the best conversations in the chat that I have seen for a long time. Yes, so I really invite you to look that up later, and maybe there are some questions directly to the presentation, the methods, the results, or anything. Otherwise, I would hand over to Alan. Is there a particular reason for showing placebos and effects for less than 10 periods?
Yeah, I think it is like when you look at the time frame.
Yeah.
So yes, we have some parks before 2010, but I guess most of the sampling after 2015. So like what we are showing is where we have kind of enough variation and data in our sample to look at these effects. Yeah, you could do the whole plot, but like the 20 years effect will be identified only of the 3 parks that were treated in 2003, right? So that's I guess the reason where those are the amount of years and parks that will give us like tight estimates.
All right. I think then we can. Yeah, thank you very much. This was a great, helpful discussion, right, on pointing to different data sources, different ways of you trying things out now. Yes, so that is really great. Yes, thank you very much.
No, thanks again for all the comments, for the invitation. This was super helpful, and we'll definitely read, and any additional comment, suggestion via email to any of us. We're happy to like improve the paper.
Right, Alan.
Thanks so much, Santiago. Yeah, I just want to join Elias and second his comments about it being really interesting work, a lot of food for thought for this group. And I'm sure you guys will be happy to receive comments offline. But just to wrap up, I just would like to mention that next month, April, I think this is our last seminar of the semester. Is that right, Elias? Oh, we have 2 more. So, and then we have Maria Alejandra Velez. Yes. So next month in April, we will have Priya Shamsundar from the Nature Conservancy. We try to, in addition to inviting academics to talk about research, we try to invite folks that are kind of at the nexus between policy and research. And so Priya's a great example of that type of person. And then she will be followed in May by Maria Alejandra Velez, who will be our last speaker of the semester. So again, thank you so much, Santiago and Prakash. Really appreciate the paper. And we look forward to staying in touch. Thanks, everybody, for your comments.
Thank you very much.